Okay, so I guess it's time for us to move on to our first lesson. So, hello, how are you? I'm Mr. Chu, uh, more known as Chu Sensei. So, starting from today on, I shall doing this YouTube live for semester one and semester three STPM chemistry. Hopefully, that you all will be able to understand the technique of how to answer STPM questions. Now, this is the best that I can do for all of you because I'm not sure how much can I help in all this, especially in this very hard time. So, well, if you don't have the exercise book, you can go to the Shopee apps and download and buy from the apps the books, okay, or you can buy through your teachers. I believe that your teachers has more informations, so hopefully you all will be able to gain something from it. Okay, so without any hesitation, let's begin our lesson, shall we? So if you're ready with the questions and answers, so I'll be able to guide you through on how to answers from objective to structure to essays. Okay, so especially for structure and essays, you already have the answer at the back behind of the books if you already own the books. So I'm more to expose on how to answer the questions on what you should know. What are the general things that you should know in order to answer the questions smoothly? So hopefully you all will be able to understand. If you have any questions, you may leave the comments and I'll try my best to answer as much as I can. So without hesitation, let's begin our lesson, shall we? So let's have a look at the questions that I've already prepared for you. So let's get on with question number one. Question number one sounds like this. Which one of the following ions has more electron than proton and more proton than neutron? So you have to understand in this case that you have proton, neutron, and electrons here. So then you have to eventually know what is the proton, neutron, and electrons inside there. So you must be able to how to put in words. You must be able to understand on how to deduce the number of proton, neutron, and electron. So how would you able to deduce? So you can see that up upon here you have these value informations. Okay, you have a hydrogen 1 1, deuterium 2 1, helium 4 2, and oxygen 6 8. So the technique is like this. Now if you want to have more electron than proton, automatically what ions must have more electrons than proton? So you must know that when you have more electron than proton, then it must be a negatively charged ions. Okay, so the answer in B and D automatically will be your first choice. So A and C you can automatically waive from it. So we then study in details on how is the number of particles for B and D. So given to you BOH, O has 8 proton, while hydrogen has 1 proton, so total up will be 9 proton. Okay, and then as for neutron, oxygen has 8, since you have 16, isn't it? So the number of neutron is going to be 8, and for hydrogen is 1, so the number of neutron is 0, so the total number of neutron is 8 here. And then it's since it is a negatively charged ions, means that you have already received an electron, so the number of electron is 10. So in here we can clearly see that the answer is D, but just in case we also check the answer as for D. So in D, okay, as we mentioned just now, proton is 8, deuterium has 1 proton, so total is 9 proton. So you have neutron 16, you have deuterium 2, so the neutron is 8 and 1, so the neutron in here is 9. So because we want to have more protons than neutrons, okay, so that is why the best answer for this question is B. Okay, okay, then that is for number one. In number two, which one of the following ions is the total number of proton is the same as the total number of neutron? So you have proton and the neutrons are the same. You try your best to highlight the important keywords inside your questions here. so that you won't be able to miss what are the things that the questions want, and more electrons than the number of proton. So again, this is automatically a very clear answer. As we mentioned just now, when you want to have more electrons than proton, it must be a negatively charged ion. So the answer is automatically B or C in here. Okay, B or C in here. Okay, so you have to check on how much is the proton, neutron, and electron for hydride ion H negative and nitrate ions. Okay, so again, I put up the tables for you so that you can clearly see on how is the answer is supposed to be for hydride ions and also nitrate ions. Okay, so because we want the same proton with the same neutron, so neutron in here you have number of protons is 7. Okay, oxygen is 8. Okay, then nitrogen is 14 total. Okay, then oxygen is 16. So that's what makes the proton, neutron, electron to be totally different case already. So in case you can already see that the proton and the neutron in here are 7 and 8 respectively. Okay, so in here you can see that neutron and proton are the same for nitrate ion. So when you total up, you have 31 neutron, 31 proton, and 32 electrons in here. So therefore, whereas for hydrogen, the proton number is 1, the nucleon number is 1, so you have 0 neutron. Okay, so in here you have 0 neutron, 1 proton, 2 electrons in here. Okay, so therefore the best answer for these questions here will be C. So this is how you answer for question number 2. Then we goes for the next question, which is question number 3. Which of the which properties is the same for the two nuclides 1418Ar and 1419 potassium? So if you see carefully on the proton number and the neutron number for both of them, we can clearly calculate the number of neutron. So the neutron in here is 22 for argon. As for the potassium, the neutron number is 21, the number of neutron. So let's have a look together. A, number of electron, are they the same? So they have different number of proton, so therefore they have different electrons. So A and D are automatically out from our answer, as we already deduced that the number of neutron in here, okay, is 22 and 21. They are different, so B is not going to be the answer. And since they have the same nucleon number 40 and 40 in here, so the best answer for these questions is C, the number of nucleons. Okay, so that is for number 3. Whereas for number 4, carbon-14 is radioactive and is used by archaeologists in carbon dating. Which species has the same number of neutron and same number of electron in the carbon-14 atoms? So in here, we want the same number of neutron and the same number of electrons. Okay, so in here, you have to eventually build the same table as we already did in question number 1 and 2. So let's have a look together at the tables that I've already made for you. Okay, so as you can see in here, carbon 14, okay, you have 8. Carbon 14 for information, the formula is 14C6. Okay, so in another word, in here, because all of them are most of the selections in here are charged, so you have to be very careful. Okay, so in here, therefore the number of neutron is for carbon is 8, number of electron is equal to the number of proton, which is 6, since it is a neutral species. So we have the selection A, B, C, D here. Let's have a look one by one for all the subparticles in here. So you can check inside the periodic tables that the proton number of the nitrogen is 7. So 14 minus 7, so you get your neutron equals to 7. Whereas nitrogen has 6 proton because it has already accepted donated 1 electron. so the number of electrons is 6. As for oxygen proton number is 8, so the number of neutron is 16 minus 8, therefore you have 8. Okay, whereas in terms of electron, since proton number is 8, when you have 2 plus means that you have already donated 2 electron, so this will make the answer is equals to 6 for oxygen 2 plus. As for C, if you check the periodic table, fluorine is 9, okay, so 7 minus 9, you have 8 neutron. And since fluorine has 9 proton, so when you become plus, means that you donated 1 electron, so the number of electron in here is 8. So as for silicon is 14. Okay, so the number of proton is 14, so that will make the number of neutron is 14 and number of electron is also 14. So in here, what is the answer for this? It is very clearly the answer is B. So this is how you are going to answer for question number 4. So for such questions, you might want to do it one by one slowly on how to deduce the number of neutron, proton, and electrons. Okay, so that is for question number 4. Then we go to question number 5. Which set of M over E values is most likely to correspond to the mass spectrum for chlorine gas? Now you have to understand by yourself that chlorine gas exists naturally as a diatomic molecule Cl2, and chlorine here has 2 isotopes, namely isotope of 35 and 37. So from the information in here, you can see 35 and 37 is referring to the isotopic mass for the chlorine, the 2 isotopes that exist for the chlorine atom. Whereas 35.5 is actually an answer calculated from the average isotopic mass together with its abundance. So the information of this 35.5, which is actually the relative atomic mass of the chlorine, cannot be detectable by mass spectrum. So this can only be calculated once you have already deduced the you have deduced the isotope for each chlorine atom and then average it with its relative abundance. So this will never exist inside the mass spectrum. Okay, so what is the best set for the chlorine? So the best set in here, so I'll give you the mass spectrum for chlorine. So showing to you here is the mass spectrum of chlorine. So in here you have Cl35 plus, okay, whereas here you have Cl37 plus. And what makes M over E equals to 70? So because chlorine exists naturally as a diatomic molecule, so the 70 is made of 35 Cl, 35 Cl, okay, plus, of course, okay, whereas 72 is made of 2 possible, which is either 35 Cl, 37 Cl, or there is another orientation that can build with it, so which is 37 Cl, 35 Cl. Okay, so these are the 2 possible orientations of the structure that makes this mass spectrum. And finally, 34 M over E 74 is made of 37 Cl, 37 Cl. Okay, so this is the mass spectrum for the chlorine atom. So what is the information that you can have in here? So the set will be 35, 37, 70, 72, and also 74. Okay, so the answer in here is point B. Okay, so that is for question number 5. So immediately we move to the next question, which is question number 6. A mass spectrum is shown below. This is the mass spectrum shown. Which of the following give the mass spectrum illustrated in the molecules in here? Now, in here, let's check one by one. What is the in here we have to consider the most stable form of the isotope for each element. Since in here there is no specific saying that they can exist in a multiple isotope. So we have to presume that all of them are monoisotopic. So if you look at the most stable form of the atom, chlorine, the carbon, the most stable is carbon 12. Okay, carbon, the most stable is carbon 12. Oxygen, the most stable is oxygen 16. Hydrogen, of course, hydrogen, the most stable form is 1. Whereas nitrogen, the most stable form is 14. And then I believe that is all that you need to know. So these are the possible mass spectrum given by each of them, and you have to use a little bit of calculations to deduce what is the possible structure given in here. So looking at the graph. So what is the m over e value for each of them? So this is happens at 14, okay, then 15, and also 16. And then the next spectra you see here is 21, 22, 23, 24, 25, 26, 27, and then this is 28. And last but not least, the last one in here will be 41, 42, 43, and 44. Okay, so in here you have to know by yourself what is the possible. The 44 in here usually shows the relative molecular mass of the spectrum involved. So what is automatically not in our answer in here already? So the automatically it cannot be a mixture. So D is already out. If you calculate properly, the total relative molecular mass for CO2 is equals to 44. Okay, whereas the NO2 is 28 plus 16 is also equals to 44, and then C3H8 in here, carbon is 16 is also equals to 44. So A, B, C will be the answer. Therefore, we have to look in details what is the possible answer in here. Now, if 14, so 14 is probably given by nitrogen and oxygen. Okay, so carbon dioxide is automatically out from our answer already because carbon and oxygen cannot give 14. Whereas nitrogen may be possible, and then carbon C3H8. Now, showing to you in here, what are the structure of C3H8 looks like. So this is how the structure of the C3H8 looks like. So it is an alkane, okay, where you can see here. Okay, so this is how C3H8 looks like. So whether it is possible to form 14, from here you can see that yes, you might form 14 when you do like this, but it is impossible because once you do like this, you have a monoatomic hydrogen. So if it is monoatomic hydrogen, in here you see 1. You see a peak in here showing that this is a 1, but in this diagram you do not see. In another word, you will not be able to get CH2 like this, okay, which will mix up the total mass is equals to 14. So with the possible mass spectrum here, so from the suggested structure, so 14 is probably given by nitrogen 14, oxygen is given by 16, okay, 28 is given by nitrogen, okay, and finally this one is the RMM, so it's probably NNO lah. So how does the Lewis structure of the N2O looks like? So this is how the structure of N2O looks like lah. Okay, so with this, the best answer for number 6 is C. Okay, so that is for question number 6. Okay, then we goes to the next one, which is question number 7. The diagram shows the mass spectrum of the sample for nature occurring copper. What is the relative atomic mass of this copper? So we can see in here the abundance for the copper 63 is 7. Okay, this is abundance 16 and 7. Okay, and then you have abundance for copper 65 is 3. So you have to use the formula. So what is the formula that you use? So RAM of the copper is equals to 63 times 7 plus 65 times 3 divided by 7 plus 3. So press your calculator, get your answer as 63.6. That is for number 7. Number 8, which of the following can be determined by using a mass spectrometer? A mass spectrometer can eventually find out what is the relative molecular mass of the organic compound, the accurate mass of the individual nuclei in here, which is also possible, the number of proton. So can you identify the number of proton from a mass spectrum? No, you can't. You cannot detect number of proton. You can only detect the mass, which is mass number, which is the number of proton plus neutron. Okay. And last but not least, the number of neutron identified element also you cannot get. Okay. So in here, best selections in here is only 1 and 2. Therefore, our best answer in here is B. Okay, so that is how we solve for question number 8. Okay, then immediately we go to question number 9. Compound PBr3 is formed when 31P, 79Br, and 81Br isotopes. The relative abundance of the 79 to 81 bromine is 50-50. Which statement about the mass spectrum of PBr3 is true? So let's have a look together at the mass spectrums that can be provided by the PBr3. So showing to you in here, the possible mass spectrums that is able to make up PBr3 might goes like this. So if this is a mass spectrums, okay, I don't have ruler, so you have to pardon me my drawing. Okay, so what is the possible peaks? You can have, of course, the most common one, which is a 31 phosphorus. Okay, and then you have 79 bromine and 81 bromine. So this is when you have normal monoatomic atoms which are separated individually. Then out of the PBr3, so showing to you here, this is the structure of how PBr3 looks like. Okay, this is how PBr3 looks like. Okay. Okay, so what is the possible structure? What is the possible mass spectrum that can be built? What is the possible fragment? Okay, possible fragments that can be built for PBr3. Of course, the first one you can build is based on the PBr in here. Okay, PBr. So in PBr, therefore, you can have two possible peaks, which is occur at 110. Okay, and also 112. Okay, so 110 is a result of P at 79Br, and 112 is a result of P at 81Br. Okay, so this is for number 1. And then number 2, what happens to the another possible structure? Another possible structure is you have PBr2 here. PBr2. So in PBr2, you have 3 possible arrangements. What are the 3 possible arrangements? So in here you have phosphorus. The peak of these two heights should be the same. Sorry that. Okay, so what is the possible PBr? So you shall have M over E at 189, 191, and then 193. So what makes 181, 191, and 193? So 189 is made of 189 is made of PBr2, PBrbr. Okay, so it is made of 79, 79. Okay, and what makes 191? 191 is made of P 79, 81 Br. Or another possible is P 81, 79 Br. Okay, so in here, the probability, what is the peak height ratio for these 3 peaks are the following. Okay, so it is because the ratio is 50-50, so it's 1 to 2 times 1 to 2. So the probability in here is 1 over 2 times 1 over 2, so you get 1 over 4. Okay, so same goes to here. Here you have 2 possible peaks, isn't it? So it's actually 1 over 2 times 1 over 2. Okay, but because it exists as 2 orientation, so you have to multiply by 2. Okay, so at the end you get 1 over 2 lah. Sorry, this one is 1 over 4. Okay, as for PBr3, this one is P81Br and 81Br. Okay, and the probability in here is half times So again, you get it goes to 1 over 4. So what is the peak ratio in here? The peak ratio of these three peaks is 1 to 2 to 1. Okay, and last but not least, the last peak probably goes to PBR3. When here, what is the possible peak for the PBR3? So it can have as 4 peaks. So what is the possible 4 peaks in here? Let's have a look together. What is the possible 4 peaks in here? Okay, so you can have number 1 occur at 79, 260, as stated, we have 268. Okay, then you also have 270, then you have 272, and then you have 274. So these are the 3 possible peaks for PBR3 whole molecule. Okay, so what makes 268? 268, as I mentioned in here, it is made of P79, 79, 79 Br. So this is made of 268. And then 270, it is made of 3 possible way. So it can be 3 possible way are 79 Br, 79 Br, 81 Br. Another possible is 81 is 79, 79, and then another one is 81, 79, 79. Okay, so there are 3 possible orientation, and same goes with 272. So 272 in here is made of P79 Br, 81 Br, 81 Br, and you have 3 possible orientation for this. What are the 3 possible orientation for this? The 3 possible orientation for this is 79, 81, 81, 81, 79, 81, and 81, 81, 79. Okay, and last but not least, what makes the 274? So 274 is 81, 81, 81. Okay, so in here, there's only one possible way to arrange this. Therefore, the peak ratio for the end of this is 1 to 3 to 3 to 1. So that is how you reduce the possibility of peak ratio for each of these fragment ions in here. Okay, so let's have a look back at the question. So A, mass spectrum of the fragment ion contain only PBr3, which is wrong. The last spectrum of mass spectra has a value 271, also wrong. The number of peak of PBr3 fragment ion is 4, which is correct. And finally, the peak intensity of all spectra of the abundance are the same, which is wrong. Okay, so the best answer in here will be C. So in here I also explain in details of how do you get the peaks in here. So hopefully you'll be able to understand it. Okay, so that is for number 9. Then we go to number 10. So gallium has 2 isotopes with the relative isotopic mass 6971. When 1.00 gram of the gallium react completely with oxygen, 1.344 gram of gallium oxide Ga2O3 is produced. By assuming the percentage of abundance of oxygen is 100%, what graph is shown by the mass spectra of gallium? Now, this is one of the very tricky and long calculative way, and you have to use the technique of how to calculate the empirical formula in order to for you to get the relative atomic mass of gallium. So is it wise to refer to the periodic table? So in this case, it is not about to refer to the periodic table, but it is for you to how to learn on how to calculate the mass spectrum. Because if you use the gallium in the periodic table, you will never be able to find the answer here. So you cannot use the periodic tables in this case. So you have to use the manual methods on how to get the relative atomic mass for gallium, and then from the relative atomic mass you can find the abundance. So how are you going to solve it? Very easy. So first of all, you have to understand that the formula of the gallium oxide is Ga2O3. Ga2O3. So in another word, if you use the empirical formula methods, the empirical formula methods of gallium is 2 to 3. So when we convert into the simplest form, it is actually equals to 1 to 1.5. Okay, so if you still remember on how to calculate empirical formula, so given to you, initially we start from 1 gram, isn't it? 1 gram of gallium. After you react with oxygen, you form 1.344. So in other words, the mass of the oxygen increased by 0.344. So mass of oxygen is 0.344. So in order to get the simplest ratio, you have to get the mole first. So how to calculate the mole of gallium? So mole of gallium is 1.00 divide by the atomic mass of the gallium. Okay, whereas oxygen is 0.344 divided by 16. Since the question already says that the percentage abundance of the oxygen is 100%, so we are going to presume that oxygen is equals to 16 in here. Okay. Okay, so after you calculate it here, 0.344 divided by 16, you get 0.0215. And in here, in order to get the abundance ratio is equals to 1, not abundance ratio, sorry. The ratio for the empirical formula is equals to 1. So it's 1.0 over AR divided by 1.0 over AR, isn't it? Okay, so in other words, you substitute in here, that is going to be the same for both of them here. Okay, so that is how we can eventually learn how to calculate atomic mass. So by applying this formula, 0.0215 divided by 1.0 divided by AR, so you can which is equals to 1.5. Eventually, after the calculations, you see that the atomic mass of the ratio is gallium is 69.8. And since the atomic gas of the ratio in gallium is 69.8, so one must be A, another one must be 100 minus A. And it's already mentioned that the gallium has two isotopes, which is 69 to 71. Okay, so as a result, after the calculation, A is equals to 60 lah. So in another word, you have two possible isotopes. The isotope 69 to gallium to 71 gallium is 60 to 40, which is eventually equals to 3 to 2. So based on the calculations in here, the best answer will be B. So that is how you solve for question number 10. It's a very long calculation, so it is not wise for you to learn how to spend too much time on calculations like this. So if you are not sure on how to solve, I usually advise students to just skip these questions. Okay, so this is from number 10. So immediately we go to the next one, which is number 11. So 11 sounds like this. Which of the following contain 1 mole of stated particles? A. Chlorine molecule is 35.5 grams of chlorine gas. So you have to understand by yourself, chlorine exists as a diatomic molecule. So for chlorine is 35.5 divided by 2 here. So because they in A in here, the question already wanted okay, you can see in here they want chlorine molecule. Okay, so not chlorine atom. So chlorine molecule, so 35.5 divided by 2 times 35.5, you get 0.5 mole. And then B, electrons in 1 gram of hydrogen gas. So hydrogen also exists naturally as the diatomic. So mole of the oxygen is 1.0 divided by 2 times 1. So you get 0.5. Okay, so it's 0.5 hydrogen. So 0.5 of hydrogen is equals to 1 mole of the hydrogen atom. So hydrogen atom is made of H11. Okay, so hydrogen has 1 proton. So in another word, you have 1 electron. So if you have 1 mole of hydrogen proton, so the 1 mole it shall have 1 mole of hydrogen electron. Okay, so as a result, the number of mole of electron is also equals to 1. Okay, and then for H2SO4, since H2SO4 is a diprotic acid, so it produces 2 more hydrogen gas. So in 2 more hydrogen gas of 1.0 in 1, so the number of mole of hydrogen gas is 2.0 mole. Finally, mole of oxygen gas. So oxygen atom. So oxygen atom is 22.4 decimeter cube of oxygen at standard temperature pressure. So 22.4 divided by 22.4, you get 1.0. Since one oxygen atom contain one oxygen molecule contain 2 oxygen atoms, so the mole of the oxygen atoms is also equals to 2 mole. So we are typing error on these oxygens. Okay, so therefore the best answer for this is B. Okay, number 12. In polluted air, the white paint pigment in the older oil painting forms tin 2 sulfide, SNS, that is black. To restore the white color, a solution of hydrogen peroxide H2O2 is used. So this is the balance equation the question will give you. What is the mass of hydrogen peroxide is required to react with 0.239 gram of tin 2 sulfide? So in here, based on the equation, you have to calculate the mole first. So how to calculate the mole of tin sulfide? So the tin sulfide start with 0.239 divided by the RMM. So 19 times 0.239 divided by 119 plus 32, you get 0.0158 mole. So stoichiometrically, 1 mole of SNS is equivalent to 4 mole of hydrogen peroxide. So mole of hydrogen peroxide here multiplied by 4, so you shall have 0.0633. So the mass of the hydrogen peroxide 0.0633 multiplied by 2 times 16 plus 2 times 1. Press your calculator, you will get your answer as the 0.215 gram. Okay, so that is for number 12. Immediately we go to the next question, which is number 13. So number 13, when potassium chlorate KClO3 is heated at its melting point, it is proportionate to potassium chlorate KClO4 and potassium chloride. So this is the equation. 4 KClO3 forms 3 KClO4 plus KClO3. Okay, so the ratio is 4 to 3 to 1. Okay, so what is the maximum number of mole of potassium chlorate which could be produced from 12.3 gram of the potassium chlorate? So first of all, calculate the mole of the potassium chlorate KClO3. So 12.3 divided by 39.1 plus 35.5 plus 3 times 16.0. So press your calculator. The mole of the KClO3 in here is going to be 0.1. Okay, mole of KClO3 is 0.1. So stoichiometrically, since 4 mole of KClO3 is to 3 mole of KClO4, okay, so the mole of KClO4 in here will be 0.075. So the answer in here is C. As for number 14, when 20 gram of the gaseous hydrocarbon were completely burned in an oxygen, 60 gram of carbon dioxide and 40 gram of water vapor were formed. All volume are measured at the same temperature and pressure. What is the formula of the hydrocarbons involved? So you have to know by yourself what is the general formula of how to the combustion of the hydrocarbon. So the general formula of the combustion for hydrocarbon goes like this. So you have CXHY plus MO2 give XCO2 plus LO2H2O. So since in here we are only given the information of carbon and water, which is enough for us to eventually deduce what is the possible number. So according to Avogadro's law, when you have 20 centimeter cube to 60, it will form 60 centimeter cube of CO2 and 40 centimeter cube of H2O. So in here you see the ratio of C to CXHY. The ratio of CXHY to CO2 to H2O is 1 to 3 to 2. So therefore, you can straight away deduce X will be equals to 3. Since stoichiometrically, 1 carbon is to 1 carbon dioxide. So if 1 hydrocarbon produces 3 carbon dioxide, so the number of carbon inside this hydrocarbon is 3. As for the hydrogen, since y over 2 is equals to 2, so you get y is equals to 4. So at the end of the day, what is the formula of the hydrocarbon involved? Is C3H4. That is for number 14. So immediately we go to question number 15. The percentage of iron in a hemoglobin molecule is 0.350%. If a hemoglobin molecule consists of 4 iron 2 ions, what is the relative molecular mass of this hemoglobin? So given to you, relative atomic mass of iron is 55.8. So in here, you have to use the mole ratio and to get the percentage. When from the percentage, you can eventually calculate the relative molecular mass. So this is how we are going to solve. So let relative molecular mass of the hemoglobin is equals to HbF4. So in here, HbF4 in here, because we want to find the molecular mass. And we know that 1 molecule of HbFe4 contain 4 mole of iron. Therefore, in terms of mass, don't forget the percentage of iron inside a hemoglobin is 0.0350 only. Okay, so 1 hemoglobin consists of 4 iron atom. So the percentage of iron in here shall be 4 times 55.8, which is from iron, divided by the molar mass. Okay, the molar mass is the hemoglobin, times 100%. Okay, times 100%. At the end, you get your total mass of the iron is total percentage of the iron by mass is 0.350. So that is what it means in here. Okay. So, as a result, you can eventually rearrange the equation to get your molecular mass. So, the molecular mass after the rearrangement, okay, in here, so it shall be 0.350 times 100 multiplied by 4 times 55.8. So, eventually you get the calculation as 6.38 times 10 power 4. So, that makes your answer is equal to C. Okay, so this is for number 15. So we go to number 16. Given the balanced chemical equation C4H4 plus 5O2 give 4CO2 plus 2H2O. Now, if 0.3618 moles of the C4H4 were allowed to react with 1.818 moles of oxygen, and this only reaction occur, what is the maximum quantity of water that can be produced? Okay, so first of all, you have to get the mole of water lah. So in here, we have to compare which one is the limitant, which one is the excess. So since 1 C4H4 react with 5 oxygen, so you have 0.3618 react with 1.809. Okay, so in here, if you multiply this one, eventually you can get this one is the limitant, which one is oxygen is the excess. Okay, so therefore we are going to use the mole of the C4H4 as to calculate in here. Okay, so in here stoichiometrically is 1 to 2, isn't it? So since stoichiometrically is 1 to 2, so 0.368 times 2, you get 0.736 multiplied by the RMM of water, okay, which is 18.0, so you get 13.0 gram. So that is for how you calculate the relative molecular mass, the mass of the water vapor produced in here. So this is number 16. Number 17, phosphorus tribromide PBr3 has a molecular mass of 271 and the mass of water is 18.0, where with phosphorus to form phosphoric acid H3PO3 and hydrogen bromide HBr in here. Okay, so if 0.500 mole of the phosphorus tribromide is reacted with 2.00 mole of water and 98.048 gram of hydrogen bromide were obtained, what is the percentage of yield from the reactions in here? So in here you have to be very careful on how to calculate the moles in here. So stoichiometrically, you have to first write a balance equation for this. So the balance equation for this reaction is PBr3 plus 3H2O with 3HBr plus 3 H3PO3. So in here you can see the mole ratio is 1 to 3 here. So mole of the HBr in here is 90, mass of the HBr, mass of the HBr is 98.048. You divided by the relative molecular mass, okay, which is 81. So eventually you get 1.21, which is the actual yield. So we have 0.500 mole of the PBr3. So the maximum yield that can be get from the PBr3 based on this 0.500 is 1.5 of the HBr in here. So how to calculate the percentage of yield? So the percentage of yield, you can use the mole concept to calculate. So you get 1.21 divided by 1.50, so you get 80.7. Okay, so here the result get you answer is not 80. Number 18, urea NH22CO is a chemical fertilizer which dissociates into carbon dioxide and ammonia gas NH3 in the presence of water. So calculate the volume of ammonia gas liberated when 4.00 gram of urea dissociated completely in water under room condition. So given to you volume is 24.4. So in here you have to build up the equations. So what is the equation when we act with water? So if you look at the question instruction carefully here, so it react with in the presence of water, that means it react with water to give ammonia and carbon dioxide. So the equation will be N2, NH2 2CO plus H2O give 2 NH3 plus CO2. So to first calculate the mole of the urea. So you got 4.00 divided by the RMM of the urea, things here. So you get 0.06897. So stoichiometrically, from the equation, 1 mole of the ammonia, 1 mole of urea give 2 mole of the ammonia. So the volume of the ammonia is 2 times 0.6897 times 24.4. Press your calculator, eventually you can get the volume of the ammonia is 3.25 decimeter cube. So this will make your answer is equals to A. Then we go to question number 19. Sodium hydrogen carbonate NaHCO3 can be used to neutralize excess acidic in a situation such as, for instance, acid spill in laboratory. So the equation for the reaction is H plus CO3 minus give H2O plus CO2. Calculate how many grams of NaHCO3 would require to neutralize 75.5 milliliter or 1.00 mole per decimeter cube of nitric acid. So first of all, you have to calculate the mole of the acid. So the mole of the acid in here, you use MB over 1000. Okay. So is 1.0. Okay. Times 75.5 divided by 1000, you get 0.075. And then mass of the stoichiometrically, because one nitric acid react with one sodium carbonate ion, isn't it? So stoichiometrically it's 1 to 1. So the mass of the sodium carbonate required, so you get mole 0.755 multiplied by 23.0 plus 1 plus 12 plus 3 times 16. Press your calculator, at the end you get 6.34 grams. Okay, so the best answer in here is C. Then we go to question number 20. Lactic acid C3H6O3 is a monoprotic acid that forms when milk becomes sour. In one laboratory exercise for students to take food chemistry course, a 40.00 milliliter sample of aqueous lactic acid in solution require 26.50 or 0.4 of sodium hydroxide to react. From this data, what is the molar concentration of lactic acid in the solution? Now, you have to be careful because in here the question already said it is a monoprotic acid. That means an acid that gives you 1 mole of the hydrogen ions in here. Okay, so even though you have lactic acid C3H6, but actually only 1 mole of hydrogen ion is given. So how to calculate this one? So you first calculate the volume of the mole of the sodium hydroxide. So you use the formula MABA equals to A over MBBB equals to B. Okay, so this is a neutralization equation. So the ratio is 1 to 1. Okay, so MA times 40 divided by 0.140 times 26.50 divided is equals to 1 to 1. So press your calculator. At the end of the day, you get your molarity of the acid is equals to 0.0928 mole per decimeter cube. So the best answer in here is A. Okay, so that is for number 20. Okay, so we go immediately to question number 21. A sample of nitrogen gas containing 40 nitrogen and 15 nitrogen isotope. Which of the following mass of a charge ratio corresponds to the N2 plus species that cannot be found from the mass spectrum? Now, if you have a mass spectrum in here, so what is the possible M over E? So you shall have this is the mass spectrum diagram. Okay, so yeah, of course you shall have at the first is the mass of the so you can see. Okay, so at first you shall have 40 and 15 that represent the mass spectrum of the nitrogen. Okay, N plus. Okay, N14 plus. Okay, and N15 plus. Okay, now if you have to form N2, so how many possible peaks that you can form in here? You form 3 possible peaks. So what are the 3 possible peaks that you can have? Is 28, 29, and also 30. Okay, so 28 is made of 1440 nitrogen, 21 9 is made of 1450 nitrogen, and 30 is made of 15 nitrogen. So which cannot be found as the mass in the nitrogen N2 plus, because the question 1 N2 plus. Question 1 N2 plus. Okay, so what is the mass that cannot be found? So the cannot be found is 14, because 14 is for monoatomic. Okay. Okay, number 22. 12 carbon and 14 carbon are isotope of the carbon. Okay, so which of the following is the same for the number of proton here, for the isotopes here? So since they are isotopes are substances that have the same number of proton or different proton number, but different nuclear number. So proton number, actually we have another phrase that describe it. So the phrase that we describe it here is nuclear charge. So nuclear charge refer to nucleus that has charge. We all know that nucleus contain proton and neutron, isn't it? So neutron has no charge, proton has charge. So that is why the terms nuclear charge came from. Okay, so nuclear charge in here is referred to the number of proton. So therefore, the best answer for this question is 4AP. Then we go to question number 23. Tritium T3 plus is a radioactive isotope of hydrogen, slowly turned into helium isotope He3. Which of the statement is true about these two isotopes? So let's have a look together. So tritium is actually a radioisotope of hydrogen, so the proton is 1, whereas the helium, the proton is 2 in here. So the answer says that T3 and He3 has the same nuclear charge. Actually, same nuclear charge means that the same number of proton. Is it true or not? Of course, it's not true. Okay, so T3 plus has the same number of neutral substance if you calculate properly. So tritium has n equals to 2. Okay, the 2 neutron, whereas helium n equals to 1. We have 1 neutron. So they have the same neutral subparticles, which is neutron. Is it true or not? Okay, so is it true or not? Neutral subatomic, which is nitrogen, is it true or not? Which is also not true. Okay, and then number 3, T3 plus He3 plus has the same number of charged atomic and subparticle species. So as we already deduced, they totally have different subparticles. So they are going to have different charged subatomic particles. And last but not least, T3 plus and He3 plus are deflected into the same point of the magnetic field, whose strengths are not varied, since they have the same mass number. Okay, that means they have the same atomic mass. So they are going to deflect in the same direction. Okay, so the best answer here is not KD. Okay, okay, so this is 23 here. For those who are not sure what is it D is explaining, now if you have an electrical field in here, okay, so if they were deflected, so since both of them has the same mass, isn't it? So no matter tritium 3 or helium 3, since they have the same mass and same charge, plus and plus in here, so they are going to deflect in the same direction. So the questions comes here. Will the proton number influence the deflection? No, it won't. Okay, number of proton will not influence the path of the deflections inside the spectrums in here. Okay, so therefore they are not going to vary. Okay. Okay, then we have 24. Which of the following correct regards to the number of proton, neutron, electron, and particles? Right? So we have to check one by one whether they are correct or not. So in terms of proton, so it seems that proton all are correct, no problem. As for neutron, so you have to mount minus 1.1 accordingly. So neutron 81 minus 35, you have 46. Automatically A is wrong. 29 divided minus by 19, you have 11, which is correct. 37 minus 17, which is 20, also correct. 127 divided minus by 54, also correct. As for number of electrons, so since you have A is already wrong, so I'm not going to look at A. But for B originally 9 proton. After accepting 1 electron, it becomes 10 electron, which is correct. Chlorine originally 17. 17 after donated 2 electron, you have 15, which is correct. Okay, and then finally, chlorine got 53 proton after receiving 3 electron, so it becomes 56 in here. So not D is wrong. So the best answer in here, there are 2 answers, which is B and C. B and C both are correct. Okay, B and C both are correct. true answer. B and C are both correct in this case. Okay, so this is for 24. Okay, as for 25, when 20 centimeter cube of gaseous sample organic X is completed, burn the excess oxygen, 40 carbon dioxide and 10 nitrogen was formed. X could be what? So in here, you have to calculate what is the possible ratio for carbon and nitrogen. Now, since in here, CXHY and Z, 20 centimeter cube produce 40 CO2 and 10 N2. So the ratio of CHY to carbon dioxide to nitrogen is 1 to 2 to 0.5. Now don't forget, because nitrogen exists naturally as a diatomic molecule. So in here, nitrogen, since N2 is equals to 0.5 mole, so N is equals to 1, 2 times 0.5, which is equals to 1. So at the end of the day, what do you want? As long as you have any formula with C equals to 2, N equals to 1, then that shall be your answer in here. So which one is possible? So number 1 is correct. Number 2 also, number 2 in here, also 2C and 1N also correct. Number 3, you have 2C and 2N, which is wrong. And number 4, you have 3C and 1N, which is also wrong. So the best idea is 1 and 2 only correct. Okay, 26. Now 26 we have discussed just now. The technique of answer is more or less the same just now. So let the relative molecular mass. Sorry because I didn't vary these questions a lot. So yeah, just straight away answer. The answer is not KD. It is the same with the question number 2019 just now. If you flip back, okay, the way of how to answer is the same. Okay, sorry for that. Okay, so this is for question number 26. Then we go to question number 27. Which statement is true about the nuclide of 6932 germanium and 7132 germanium? Okay. A. Mass spectrum shows 2 peaks, which is correct. Okay, since it is only 2 isotopes, so you're going to see 2 peaks in here, which is correct. 69 and 71 has different atomic radius. Now in here, because proton is the same, and because they are not charged, electron also the same, so they are going to have the same radius in here. Okay. So they are going to have the same radius. Okay, and then so B is wrong. As for C, 6932 germanium and 7132 germanium react with chlorine gas. Since they have the same number of electrons, they are going to have the same chemical property. Okay, they are going to have the same chemical property. So here, C is also wrong. And 69 germanium and 71 germanium has different nuclear charge. Nuclear charge is reference to number of protons, so they are the same. So they are also wrong. Okay, so the best answer in here is A. 28. Urea N2,2-CHCO is a chemical fertilizer which reacts with water to form carbon dioxide and ammonia. Calculate the number of mole of gas released when 5.0 gram of urea completely reacts with water. Okay, so you have to write the balance equation again. So NH2CO plus H2O give 2NH3 plus CO2. So because they want the number of mole of gas released. So in here, you have to understand ammonia is gas. Carbon dioxide is also gas. So total mole of gas in here is 3 mole of gas. So if you have 0, after you calculate the mole of the urea, so urea is 0.0833 mole. So since 1 mole produces 3 mole of gas, so total mole of gas is multiplied by 3, so you get 0.25. So the answer is C. Okay, then 39. Carbon-12 isotope is used as a standard to determine atomic mass of element. Which statement about carbon-12 is true? Its relative isotopic mass is 12.01. No, the moment that you have 0.1 is definitely not isotopic mass. Okay, it is usually atomic mass because only atomic mass is decimal points. So it is volatile under normal condition because it is a solid, so it will not be volatile. Okay. So it is the most stable form of the isotope, which is true because carbon-12 has the most abundance, so usually it's the most stable. And it has different electron, proton, neutron. Since carbon is 1612, so 12, It's carbon 6. So you have proton, neutron, electron, all equals to 6. Okay, so the best answer is C. Okay, then we have question number 30. The mass spectrum of the diatomic gas W is given below. Which statement about this is true? Okay, so you have the relative atomic mass of the W is 80. So in here is 158, 160, and 162. So don't forget this W. So if it is W, the big ratio is 79 and 81. Actually, W is bromine. Okay, 7981. So, and if you see the ratio, the ratio in here is 1 to 2 to 1. That means the big ratio for this one is 1 to 1. Okay, so 79.1 plus 89.1 multiplied by this one, so you get the abundance ratio is equals to 80. So relative atomic mass is 80 is correct. Okay, the W has two isotope abundance that is almost the same, also correct. So the peak over mass ratio is 102 is produced by 81 W2 plus is also correct, and the peak over for the mass overcharge is 160 due to the molecular mass W2, which is wrong. Because I already told you just now, you will not be able to detect the relative atomic mass, hence calculate the relative molecular mass just like that. Okay, so the answer D is not wrong. It's true. So the best answer in here is A. Okay. Okay. So with that, that is the first lessons for today for semester 1. So I'm going to end for today, and we shall continue with the rest of the questions for chapter 1 tomorrow lesson. Okay. So I hope that you are doing well later, and I'll see you on our next lesson tomorrow. Okay. See you around. Bye.